welcome to the Four Patients Podcast. My name is Gabriel Uriola, and I'm a third-year medical student at the University of California, Davis. The goal of this podcast is to make world-class knowledge, research, and clinical jewels accessible to everyday people just like you. And remember, your health is in your own hands. Our next guest is a cardiologist, evolutionary biologist, award-winning professor at UCLA and Harvard, and a New York Times best-selling author. I guess most importantly, she's a former professor of mine and an inspiration to me as an up-and-coming scientist and student doctor. Dr. Barbara Natterson Horowitz is redrawing the boundaries of human medicine. She has pioneered a new scientific lens that can find solutions to human health challenges by looking at nature and evolution. During today's conversation, we talk about evolutionary medicine and her new book, Wildhood, which looks how all adolescents across all species face four high-stake tests: safety, status, sex, and self-reliance. Don't miss out because we explain how this relates to teenage depression, anxiety, risky behaviors, peer pressure, the cautions of social media, and so much more. Stay tuned. Dr. Natterson Horowitz, welcome to the Four Patients Podcast.
I'm glad to be here.
Yeah, thank you for coming on. I'm super excited, as you know, through all the emails. I kind of wanted to start us off with something to the audience might think I'm a crazy person, but I want you to talk a little bit how you can tie these topics together. So giraffes, heart health, and pregnant mothers. How do all those things tie together?
Great. I love it. The high bar in the beginning. So I should just say by way of background, as you know, I'm a cardiologist and I'm an evolutionary biologist. But as a cardiologist, I have spent, a couple of decades taking care of human beings with all kinds of cardiac issues, one of which is high blood pressure, hypertension. And as you know, hypertension can cause, if it's not detected and treated, can cause a whole range of problems, including heart failure. And what often happens is that high blood pressure makes the heart work very hard. The left ventricle has to work very hard. And when a muscle has to work very hard, it grows, it thickens. And that is exactly what happens to the heart. The left ventricle begins to thicken when there's long-standing high blood pressure. And when it thickens, it begins to also stiffen. So what that means is that your heart might be contracting pretty good, but when it relaxes, it doesn't fully relax. And so the pressure inside that heart rises and rises and rises. And eventually that pressure rises into the upper chamber of the heart, it backs into the lungs, and patients experience shortness of breath. They find it hard to move very far, very fast, and they have heart failure symptoms. So in this way, high blood pressure causes the heart muscle to weaken and lead to heart failure. So it turns out this particular type of heart failure is growing. The numbers are increasing more than any other type of heart failure, and it's the leading cause of heart failure in women. And I'm very interested in women's cardiovascular health. Okay, so that's hearts. So check. You wanted me to put the.
Hey,
okay, so,
yeah, I gave you a lot. Sorry.
So that's the cardiology part of me. But I'm also an evolutionary biologist. And one of the really exciting parts of this emerging field called evolutionary medicine is that it allows us to focus on the natural world and biodiversity. So we're talking about all of the many, the countless millions of other species on Earth, and to begin to see whether within that diversity of species, there is physiology. There's, when you see a zebra looks different than a flamingo. We know that from the outside, but the physiology is different, right? So there's not just diversity of shape and size and color. There's physiologic diversity. And so there's an opportunity to think, well, maybe contained within that biodiversity of life on Earth, there could be physiologies that have evolved that actually can solve some of the medical problems that we have not been able to. And one of those medical challenges is dealing with the negative effects of high blood pressure. So I just mentioned that high blood pressure can cause the heart to fail, but high blood pressure can also cause kidney failure and eye problems. And high blood pressure is one of the leading causes of fetal and maternal mortality in human pregnancy. Okay.
Yes.
So you can see where I'm going there. So now let's just say, can we turn to the natural world? Is there a physiology that has learned to adapt to high blood pressure in such a way that an organism is protected? And the answer is yes. At that species is the giraffe. Okay, so why the giraffe? Well, what is the most iconic feature of the giraffe? The long neck. The long neck.
Long
The
neck. Yep.
giraffe has a normal, healthy adult giraffe has a heart that is separated. So if the heart's down sort of at the body between the two front legs, the brain is up to 3 meters vertically above. So what that means is, in order for that ventricle, the heart, the left ventricle, to pump blood to reach the brain, it's pushing up against gravity, right? A column of fluid against gravity. And so related to that is the reality that the blood pressure of a normal, healthy adult giraffe can be as high as 300 millimeters of mercury over 200. And remember that for us, right, 120 over
That's
80.
crazy. 200 is like end organ damage for humans. So 300 is nuts.
Right, 300. And if you compared, which I have, giraffes to horses to other, animals in that category, it's an outlier, very, very high. Okay. So if giraffes have this very high blood pressure, and by the way, giraffes have the highest blood pressure of any animal on earth, then the next question to ask is, well, if high blood pressure causes so many health issues in humans, how is it that giraffes are running around their entire lifetimes with these high blood pressures? Why don't they all have heart failure? Why don't they all have kidney failure? Why aren't all of the pregnancies unsuccessful? And the answer is
Exactly.
evolution. They
Yes.
have evolved adaptations that protect themselves, essentially, that over the course of, as it turns out, about 11.5 million years, and we know that, and I'll tell you why, but they've evolved these adaptations that allow them to have the long neck and all the advantages, the survival advantages of having the long neck, but to not have the negative impact of high blood pressure. And so that is a really exciting piece of my research, is to understand how that evolved, what the exact mechanism is that protects the hearts, for example, and then to take those insights and direct our attention to pregnancy. How is it that the pregnant giraffe, who has this very high blood pressure compared to humans, how does she stay healthy? And that is interesting for giraffes, but it also opens up an entirely new and fascinating field of research, which is looking at pregnancy in the wild. Because, a giraffe is one
Yes.
example. A giraffe, by the end of her 9-month pregnancy, almost 10 months, 9 months pregnancy, she's put on hundreds of pounds, right, of fetus, of fluid, and of fat. And yet she's a prey, giraffe. Every single day they're being tracked and hunted by cheetahs and lions. And she cannot be the slowest giraffe in the herd. So, and that goes for a pregnant zebra and a pregnant, so there are some adaptations in the wild pregnancy that allow these animals to not lose speed. And that, I mean, when I was a cardiology fellow or a first year attending when I was pregnant with my first, and I remember running to a code blue and just, I was definitely the slowest giraffe in the herd. I would have been the slowest. So that's kind of it. And by the way, the predators too. If you're gonna eat and you're a predator and you're pregnant, and by the way, you're eating for two, you can't be slower than before. So there's this just whole kind of turning to nature for insights into human health. And
Yes.
since women's health has been so understudied, why not start with high impact issues in women's health?
Yes. And so for those of you who don't know, I was actually a former student of Dr. Natterson Horowitz. I took her evolutionary medicine class, and every time I hear her speak, I'm like mind blown by a new fact or a new way to apply these principles. And I think it's like very important because we think of humans as like, oh, we're very unique, which we are, but we're also related to animals and nature in so many ways. And you just said so greatly how we are related. Animals get pregnant, and reading your previous book. I actually have it right here. We're not going to go into it, guys, but I kind of want to, I want to plug it because I think it's an important book and amazing. Animals
Thank
get
you.
cancer. Animals can get STDs. They can get heart failure, as you mentioned, and like so many other things. And like learning about these adaptations can really help us learn about human health. So I think this is like super interesting. Learning about super moms and humans and giraffes, that's really cool.
I love
Um,
it. For moms.
so I want to talk a little bit about why is understanding evolution, and you talked about it now, but why is it so important and why is it neglected in medicine and then the way we're taught?
Right, right. So it's a great question. And I started my career as a traditional physician. I mean, I wasn't thinking, oh, I'm going to be an evolutionary biologist and combine animal and human health. Not at all. However, like you, when I was an undergraduate, I took some courses in evolution. And I always thought it was really interesting. It was a long time ago, and we didn't have comparative genomics back then. We didn't have a lot of brain imaging. A lot of science has happened. However, I had two really famous. E.O. Wilson was my freshman bio teacher, and E.O. Wilson is wrote sociobiology, and he
Yes.
really it's very famous. And then Stephen Jay Gould was another one of my professors. He was one of my thesis advisors, actually. Um, but so then I went to medical school, and went became a physician. Actually, I also grew up in California. Grew up in L.A. and then I went to Harvard as an undergrad, did a year of graduate school there, but I came back to UC San Francisco, sort of all UC all the time. And excuse me, sorry about that.
Don't worry.
Um, and anyway, I was practicing, so I did my training in internal medicine and cardiology at UCLA, and it was about I'd been on faculty for maybe 15 years or, for a fair amount of time. I was doing a lot of cardiac imaging, a lot of heart failure. And then one day I got a call from the Los Angeles Zoo who wanted me to help with some of their animal patients who had cardiac issues. And that really, the light bulb went off for me. And I started, that began a journey of first just realizing that whether it was heart failure or atrial fibrillation, right, or whatever mitral valve disease or breast cancer or kidney failure or even psychiatric diseases like compulsive disorder rather, and anxiety and eating disorders, sexual dysfunction, that all of those things did occur sometimes in other species. But my training had been so human centered, like the anthropocentrism of medicine, but it really was so human centered that in those first years, I just kept having my mind blown because I had such I felt very well trained. I was very proud. I'm very lucky to train at some amazing places, and so to have this entire world that I had never heard really about. Like I cannot remember a single time in medical school or residency or even as an attending where we were talking about heart failure in a dog or heart failure in a giraffe or when we were talking about heart failure. So that was really eye opening. And but then what I started to see is that if we want to get insights for human health from the health of other animals, we have to think about our common ancestry with that species. So breast cancer is a really, really good example. I published a paper about a year and a half ago um, called Female Health Across the Tree of Life in PNAS Nexus. And in this paper, I looked at breast cancer and ovarian cancer and some endometrial issues across species. In the case of mammary cancer, mammals. And as I started to develop lists of other mammals, whether it's koalas or whether it's walruses or whether it's, beluga whales, in whom cases of breast cancer has been seen, I'm able to build a model. And that model it's called a phylogeny, but it's like a family tree. And we can suddenly see, okay, vulnerability to breast cancer exists in all of these lineages of mammals. And that suggests that common ancestor of mammals, right? That 200 million year old common ancestor of you and me and my dog who's next door and, all of the mammals, the squirrels and the rodents in my backyard, that that this vulnerability is really ancient. So that while we modern humans, we do a lot of things, we maybe eat the wrong things, our lifestyles are not conducive to breast health. Of course, that's true. But a perspective that's missing in medicine, was missing in my medical training, was, well, that is true, but that's one part of causation. Why are we vulnerable in the first place? Why did we evolve? Why did we humans or we mammals evolve to have breast tissue that under certain conditions can develop cancer? And so evolution, that lens lets you ask two really important questions that you don't really, at least back then, I didn't learn in medical school, but it's not really part still of the physician's language. One question is, why are we vulnerable to disease? So you remember from the course that there are some
Yes.
really interesting ways we can answer that. You remember the first example that I use is fainting. So a lot of the students in the class, they're like between 19 and 22. And there a lot of UCLA students do give blood at the blood drive. And so I say, hey, has anyone ever fainted when you've given blood?
My roommate.
And
My roommate. Yeah.
if somebody always, and it turns out what happens to some people is that when they get scared, their heart rate can sometimes get very slow instead of speeding up. You think of like fight and flight, it should, but instead they get very slow. And that not enough blood is perfusing the brain, there's fainting. So if you think about that with only human beings, you think, well, that's just paradoxical. That doesn't make any sense at all. When you're scared, your heart rate should accelerate. You should, it shouldn't slow down. But if you think in a evolutionary way, sort of what I call a species spanning way, and you start to pull back the lens and you sort of say, okay, here's Homo sapiens, but we're only one of, millions of other mammalian species even. As we begin to pull back, we can say, wait a minute, um, are there other animals that sometimes also have a slowing of the heart rate? And then we say, oh, yeah, it can happen in this mammal. Oh, yeah, look, it happened in that mammal. Oh, yeah, look, it happens in birds. Oh, yes, it can even happen in fish. And all of a sudden, we get to ask that question. Well, if all of these animals have some trait, and if we hypothesize that the common ancestor of all those animals had that trait and that it's persisted, it must be conferring some survival benefit. And of course, as you know, I then show a series of videos of wild animals who are saved, whose lives are saved because they have fainted, and a predator will essentially move away or get distracted. Will be under the assumption that this one's locked in, and they
Yes.
release their grip. So it just gives you this expanded sort of diagnostic vocabulary.
Yeah.
Evolution does.
Totally, and I agree. I'm gonna go on a tangent a little bit, but I want to mention that you listed a few animals, but dogs. I feel like if we talk about dogs, all the dog lovers are gonna listen. So we gotta focus on them. Um, but yes, I agree that as scientists and as medical schools, medical trainees, we're taught to follow the science. And clinical trials, randomized control trials, meta-analyses, we're taught and we're to look at the data and apply these concepts to people and to patients. But like, what greater data is not just 10 years, 20 years, millions and hundreds of thousands of years across multiple species. So I think your work is fascinating, and this is why like I think it's so important and so interesting, is that like we're kind of ignoring so much of our shared history and thousands of years, like you've mentioned. And
Yeah,
this kind of
go ahead.
I was going to say, and this kind of brings me to a phenomenal book that I've read. It's called Wildhood. And I think one thing that we think about disease, right? Okay, everyone's like, oh, that makes sense. But what about behavior?
Mhm.
And better yet than behavior, what about puberty? So, Dr. Natterson Horowitz, can you kind of define what wildhood is and
Right.
what it means for everybody?
Sure. So the first book Catherine Bowers and I wrote was called Zubiquity, and Zubiquity was a book which the premise was that there's a lot that we can learn about, a lot that we physicians can learn about human health by sort of opening up our eyes and, as I say in class over and over, pulling off that blindfold of human exceptionalism and just kind of moving beyond the reflexic assumption that something is uniquely human. Like just because you haven't heard about it in another species doesn't mean that that species is invulnerable. There's been this kind of, human focused idea. So Zubiquity looked at cancer, heart disease, psychiatric illnesses, and so it was really pretty medical. But one of the chapters in Zubiquity looked at adolescence, and the reason we looked at adolescence is that adolescence is one of the most dangerous periods in a person's life. I mean, dangerous as in like physically dangerous. The mortality, the CDC has data that between 12 and 19, the mortality goes up in some cases sixfold, right? And that's a lot. And so if you aren't thinking like an evolutionary biologist, and you might say, well, why is that? And you probably have studied this, right? So when we talk about adolescence and that it's dangerous and they get in a lot of accidents, we talk about risk taking. And then invariably somebody says the reason is that the adolescents have an underdeveloped prefrontal cortex, right? You've heard that.
Until 25 or 27, right?
Well,
That's
yeah,
usually what they say.
concept is that that's the reason. Okay, so the neuroscience is what it is. That's true. But the question is why, right? The evolutionary question is, why did we as a species evolve to have this specific developmental pattern of brain development, between the juvenile and the adult stage? And while we're at it, let's ask, are there other species that share this particularly sort of staggered form of brain development between the onset of puberty and mature adulthood? And what Catherine and I found was that absolutely, it is not uniquely human, that you see unique brain biology in adolescence across a very wide range of just vertebrates. We found it in fish, reptiles, birds, and mammals. And all of that is gobbledygook, except when you translate it, it comes down to one thing. That brain biology is there because it promotes a certain kind of behavior, right? Behavior is the product of neurobiology. And what the behavior that it promotes, it facilitates, comes from an increased interest in what is new. Neophilia is what it's called. So adolescent animals, including us, but not just us, are more neophilic than older animals and younger animals, because the older ones are, wizened to it, and the juveniles are scared. Okay, so number one, that neurobiology is absolutely species spanning. Number two, adolescents underestimate risk. So adolescent fish underestimate risk, adolescent birds underestimate risk, and we underestimate risk. And as the brain gets more, kind of the prefrontal cortex, the whole thing that changes. And then one of the other really interesting things is that they prefer and more excited by and listen to their peers more than their parents during this transitional period. And you see this in animal experiments that, you can read it and not recognize that what is actually happening here is that these rats, these adolescent rats who were with their moms and, they learned to eat certain foods. And in the case of some of these experiments, the investigators gave these, juvenile rats food that was delicious, food that was unpalatable, and then food that had been contaminated with something that made them sick, vomit. And when they hit, I think it was 42 days, which was the adolescent age, and they entered a group of their peers, from day one, those rats that when they were with their mom were consistently avoiding the food that was making them sick, were not eating the stuff that didn't have any taste. They were like eating the regular food. Immediately, if the experimenters had the peers eating the food that made them sick, that's all they would eat, the new ones. In other words, they shifted their preference to what their peers were eating. So that is, as somebody who's had adolescence, that is it made me like literally stop. I was like, this is fascinating. So, and there are reasons for that. But in the case of adolescence, it's a dangerous period, partly because it's important that adolescents take risks. They have to take risks as they're growing up. And I'm talking about adolescents in general, not just humans. If they don't take risks, then they aren't going to gain the experiences that they need to ultimately be safe, to protect themselves from predators, and to be able to find food for themselves. So we decided to call our book Wildhood because there are so many commonalities between animals who are in this phase of life, between the onset of puberty and mature adulthood, that and that the definition of adolescence is fuzzy, right? Like, as you said, like the neurobiologists, some will say, oh, the brain is developing until 25. Adolescence continues until 25. But then if you ask, I ask the students who are in my college courses, I say, do you guys consider yourselves to be adolescents? They're all like, no, 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 we're young adults. Adolescence is like middle school and high school. So that term is just, we thought, let's just take that term, throw it away, and come up with something and really emphasize the fact that it's wild. It's not uniquely human. But the fact that it's wild, the fact that we can study the transition to adulthood in other species means that we can potentially learn about some of the things that are so mysterious and so, frankly, terrifying about human adolescence.
Totally. And I think it kind of gives you a little bit of empathy for teenagers and when they're reckless and they're driving and they're doing all these crazy things. It kind of gives you a little bit of empathy. But I think as a parent, kind of listening to this, it kind of gives you a little bit of like maybe like understanding of the teens. And you bring up this concept of safety and danger and how
Yeah.
there's kind of like a dance between safety and danger. And you cannot have one or without the other. Because if you're too safe, then you're at danger and you're at risk of getting other threats. But if you're in too much
Yep.
danger, then you can't be safe. So it's this interesting balance. So I kind of want you to talk about this. And
Yep.
there's a very interesting, cute penguin in your
Mhm.
book called Ursula, and she does this dance. So can you tell us who Ursula is, and then how she does safety and danger, and why is that so important?
Yeah. So there are four. We found that there are four tests essentially of wildhood that an animal has to pass in order to become an adult, a safe, healthy adult. And in the wild, if you don't pass all those tests, you don't survive. Now, in our species, there are a lot of people who have not completed all four, who are adults in kind of number only, but not in the wild. And the first test is learning to stay safe. And we're talking about animals. So as juveniles, in the case of birds and mammals, they're protected by parents. And but at a certain point, an animal that gets big enough to now be outside of sort of direct parental protection and go out on their own, in the beginning, they're dangerously inexperienced. And inexperience is deadly in nature. And so one of the biggest issues of safety is that um, an animal, whether, and this is, we were able to show this in, I mean, you see it in all kinds of bird species, that the first week of fledging, they are targeted by predators. They are in great danger. They fall for everything. They're what's called predator naive. And the predators know it because this is easy prey, right? These are inexperienced animals. They're big in body, but they're not smart. They're inexperienced. So you see it in all these species that inexperience is really dangerous. But the paradox or the problem is that in order to be safe, you need to gain experience. But the process of gaining experience, that can actually put you at risk. So how do you get the question is, how can you evolve a strategy that gets your youngsters, your emerging adults, the experience they need with minimizing the risk that they're going to end up as somebody's dinner? And one of the really interesting things that we learned in writing this book is that in many species, young adults will engage in this behavior where they actually, instead of running away from predators, they approach predators. They actually go toward the predator and look at them and smell them and learn about them. It's called predator inspection. And it sounds crazy, right? But you see it in lots of species. But here's the thing about predator inspection. And there's, I think, something we can definitely learn about keeping human adolescents safe. they they don't do it alone. They do it in groups. It is a group activity, and that that there's safety in numbers. There is, but it's also interesting that at least in the case of these Thompson gazelle or some of these, I mean, we're talking about gazelle adolescents, bats, um, minnows, guppies. I mean, you see this when they get together with their peers, they take more risks. When they get together with their peers, they underestimate risk, which makes them take more risks. Right? They're underestimating it. They're more impulsive, and so that neurobiology creates a scenario where you've got these gazelle coming together, and all of a sudden, instead of running away from the cheetah, you see them approaching the cheetah. They're with their peers. Now, here's what gets interesting. When you got your driver's license, when maybe you got your learner's permit in 15 and a half, you got your license at 16?
Yep. No,
Okay.
I think I
So
got a 15 and a half. My mom was probably, scared because 15 and a half, I was trying to get in the car and get out the door.
okay, so but do you remember for that first year after you got your license, you weren't allowed to drive, you weren't in California, you're not allowed to drive with anybody who's under, I think, 25 or 21.
Oh, yes. During your permit, yes.
Yeah, well, even after the first year of having a license. So you basically, unless you have an older person in the car, you can't drive alone with a bunch of high school students. And the reason for that is statistically the rates of tragic accidents, car accidents, are much higher when new drivers are with their peers. And it's interesting that you see this neurobiology in fish, in birds, and in non-human mammals, that when young animals come together, they take more risks, and it facilitates predator inspection. But my hypothesis is that maybe the evolutionary reason that we see this phenomenon of more crashes when kids are in the car with their peers is that this is part of this young adult animal brain evolution. So that's a kind of, that was a big aha moment for me. It made a lot of sense.
Yeah. So instead of seeing risk as like something dumb that teenagers do, as a parent, we can kind of see risk as like, oh, this is their way of playing with danger so that in the future they're safe. And
Right.
unfortunately, yeah, but it doesn't always turn out.
Yeah.
But yeah, that's a great point.
Yeah, but the urge to do those things has an evolutionary origin. The problem is like we don't, Ursula was a king penguin. So one of the things we did in the book is we made our points. In the case of safety, we made our points using the stories of actual animals who had been tracked by wildlife biologists. So we had the data. And one of the groups of animals that we used were a group of king penguins who were at there's an island off about 1,000 miles off the coast of South America. Of Antarctica, and there was a group of penguins. It was 2007, but this happens every year. The eggs are laid, right? You have the chicks, and the chicks turn into fledglings, and then one day, the whole class of 2007 jumps into the icy waters for the first time, and they are on their own effectively. They are not getting food from mom and dad anymore. They're extremely inexperienced. So predators know that, and they've got to eat. So you know where they hang out? They hang out right around this cove, this St. George's Island. And what you find is that statistically, of 100 adolescent penguins that are jumping in for the first time, only about 30% will make it back by the end of the year. So it's like a seven. In some years, it's a 70% mortality. But it's very interesting as you watch the data, because if they do make it back, if they are part of the lucky 30%, the next year when they go, more like 60% of them come back. And then if they're part of that 60% that survived and they go again, they're up at 90%. So it's very dangerous for them, but the learning experience is, you can see how experience makes them safe and inexperience is dangerous. We're not no parent in the world is going to accept those odds. So that's, but it does kind of help to realize just how dangerous inexperience is, whether you're going out in the wild by yourself for the first time as an animal, or the first time you do anything where there's financial danger or social danger. When you're inexperienced, if there's someone out there who wants to exploit, you're a pretty good target.
Yeah. And I think a good take home point for this is that risk, although it's risky, it's adaptive and it's important. And getting, adolescents, teenagers, young adults exposed to risk in small, healthy ways is better than avoiding them from it at all.
Yes, absolutely. And there are species where this has been natural experiments that show what happens when young fish, for example, if they're not given a chance to spend time with what are called conspecifics, which are their peers, some of whom have had, near misses with predators in the water. If they don't have time to learn how to school, like literally how to navigate, they are a mess. I mean, they are easy prey. They can't navigate social systems. So, yeah, I mean, it, it's pretty interesting to think about it from a human perspective. And my kids, by the time I was done with the book, the last one was sort of out of that phase of life. But so I couldn't really do anything about it, but I kept kicking myself for not having understood what I should have done. So,
Great point. Great point. So we talked a little bit about peer pressure with safety. Now I kind of want to talk about peer pressure with fitting in. So there's a concept in your book that's called the oddity effect. And from my understanding is that if you're the odd one out, you bring the group risks.
right.
So there's a series of experiments. I think they did it with zebra. They did it with wildebeests. That are very interesting. So can you talk about like why teenagers give into peer pressure and why it might not be as crazy as we think it is?
Yeah. So first of all, I say
To
this.
fit in relation to fitting in.
Yeah, absolutely. And Gabriel, this is the first time I've done a podcast with someone who was my student. So I'm just like beaming because these are all some of my favorite points from the class. Like, I don't know what grade you got in the class. I suspect you got an A, but you definitely get an A plus. Yeah, this is one of the, this was one of the most interesting. So first of all, I should say that it's not clear how much takeaway we can, exactly what the translational benefit is to understanding humans from understanding this fish behavior. Okay, so that's my caveat. On the other hand, we know that when it comes to human brain function and particularly vulnerability to psychiatric disease, that 75% of the genes underlying human psychiatric disease, there are orthologs in zebrafish. So there's a lot that's common, but there are differences too. But here's what the oddity effect is. So the oddity effect is the inverse of the conformity effect. And one of the things you see in groups of animals, so schools of fish, flocks of birds, and herds of caribou or whatever is that if you look at them, just visualize a school of fish, right? You're staring at them and you know that they are individuals, but they all kind of look the same, right? Their external phenotype, their size, their color, their shape, very similar. That's not accidental. It turns out that it is an anti-predator defense. And when an underwater predator is looking at a school of fish, if they're all extremely similar, it's hard for that animal to track on one. So the conformity effect actually keeps the individuals who are in the group safe. And that's so baked into the neurobiology of these fish is neurobiology of schooling that, they swim the same. There's this remarkable, it's beautiful when we see it at an aquarium, in a movie. And the same thing with birds. Think of those starlings, those incredible configurations of birds. All right. So that's the conformity. The inverse is the oddity. effect. And the oddity effect is fascinating because if what it means is that basically related to conformity, if there's one odd, if there's one individual that doesn't look exactly the same, if there's some difference, so that individual is definitely more likely to attract the attention of a predator. But the problem, and what's so interesting and maybe relevant to how we other certain individuals, is that the entire group's safety is threatened by having one odd individual. So by having that one odd individual, and they've done these experiments where they have, they dye the fish so that some of them are brown and some of them are, blue. And they create a situation where maybe they have, 8 brown fish and 1 blue fish. And over, the predator picks off the blue fish. But over and over, the predator is moving toward the school that has the odd individual. And so what you would predict as an adaptive consequence is that when fish are coming together and assorting themselves, right, when they're trying to figure out, am I going to be in this school? Am I going to be in this school? There is the assortment process essentially rejects or excludes non-conforming odd individuals. That's the oddity effect. So, it's pretty interesting. Again, how much we can make of that in terms of understanding our human tendency to fear and reject what is different from us. I don't know, but I think it's a worthy question to ask.
Yes. And it kind of brings me back to middle school or high school when I'd ask my mom, like, hey, can I get that JanSport backpack that everybody's wearing? Or can I wear those? Can I get those Nikes or the Air Force Ones? And it kind of just goes to show that, like, fitting into your group can keep you safe. And that's probably why these teenagers, and we kind of, like, as adults, we're kind of like, oh, like, why do you care what other people think about you? But we
Yeah.
have this wiring that shows that if you don't care to fit in, then you could be putting yourself and everyone at risk. And actually,
Yeah.
in my wet lab, it was very interesting. And when I read your book, I was like, oh wow, there was the link. So in my wet lab, we're doing neuroscience, research on some rats, and I noticed that when we took one of the adolescent rats, we
Hmm.
did an experiment, and then they looked a little bit different, and then you put them back, and I watched them a little bit, and the rats would bully, push,
Yeah.
and I was like, wow, like, just because of that small interaction, the his peers who were once cuddling and playing with him immediately started turning on him that quickly because he was
It,
different.
it's
So
so
interesting.
interesting. Yeah, there's that we could, I mean, I'm fascinated by this whole, I mean, by the way, isn't it, when we're talking about this, I remember really getting deep into this idea that for all of my life, I'd looked at flocks of birds and I really had not thought of them as individuals. I really, uh, I just didn't. I mean, to be honest, or if we would go to the Monterey Aquarium or even Long Beach Aquarium, and they have those. I think it's at Monterey. They have those sardine tanks, right, where they're going around. And but now I know each one of them is an individual. Each one of them has a different temperament. They have a different health history. They have a different life. I mean, and that part of those differences is they're socially different. There's a hierarchy, even in a group of anchovies. And so just beginning to pay attention to that is another one of those kind of aha type moments. It's funny when I was finishing, I think we just finished writing the book, and our son was like, I forget, he was just out of middle school, but still, had that. I'm trying to remember how old he was. He doesn't matter how old he was. I asked him, Charlie, um, what is the key to being like happy or in middle school or something like that? And he just, I remember I was in this room and I looked out the door and I said, what's the secret to being popular or just being whatever? And he just looked at me and he went, don't be weird. And it was just, it was like said to a mother asking an annoying question succinctly. And I just thought, yeah, that is probably solid advice for, middle school. But
Yeah, don't
maybe
be weird.
don't be weird.
The oddity effect at its finest.
Don't be weird. Yeah. So,
There's
but again, I think there's something to be said for thinking about that and whether some of the neurobiology and the social patterning that we see in fish, maybe that exists in some way in us, but I don't know. It's a question, not a
Yeah.
claim.
Yes. And I think that's a great point. When having this conversation, that we see a lot of correlations, but we're bringing this up as questions, and trying to trigger thought and ideas. So I think the next thought and idea that you talked about in your book was something around status and popularity. And um, I know with like the rise of social media, there's increasing rates that people are trying to correlate it, that it's due to um, trying to gain popularity and status and comparing, and that's causing these increases in anxiety and depression. So I kind of want to bring up the question to you, is that why does status matter so much, and like, should we care about it?
Right. Well, part of it, I mean, it's a great question. And the problem is the word status. Like, I kind of don't like that word because it connotes like status symbol. I mean, I'm thinking of like designer purses and sports cars. And so, if we can just take the word and like strip out all of the cultural meaning and just have it mean sort of rank, which is also not a great word. But the point is that
Yeah.
when animals come together in groups, there's a spontaneous effect that hierarchies are formed. Different kinds of hierarchies, but hierarchies happen. And uh, the vertebrate brain has this social brain network that's that exquisitely tuned into where where that individual is on the social hierarchy. So it allows them to assess accurately and then to behave properly relative to that. So um, what's fascinating about this is that the neurobiology in fish, for example, when a fish falls in status on that fish hierarchy, one of the systems that the neurobiological systems that we see the most change in is the 5-HTR receptor. So the serotonergic system is very moves closely with changes in rank. And in fact, if a fish falls in status, right, they lose some bout, a contest, they fall and they fall again and they fall again. By the time you're looking at the neurobiology, and they do this, they sacrifice the fish and they look at their brains, but the neurobiology of the fish who's at the bottom is very different from the fish who's at the top. And the videos that I show in class, you can see that the behavior is very different. The fish at the bottom is has withdrawn very often, sort of at the edge of the tank. They're not, their gills aren't moving very much. They're slowed down. Whereas the fish who has won, who has kind of ascended, it looks like a victory dance. I mean, there's a lot of movement. And what's so interesting about this is that if you, and you're as a medical student, you're probably already thinking, that sort of sounds like neurovegetative symptoms of depression in humans, right?
Yes.
The severely depressed human may have slowing of cognition, slowing of motor function. They may withdraw. They may, not be eating as much. They may be not getting pleasure from, interaction. When investigators put SSRIs, so drugs like Prozac and Zoloft and et cetera, into the water, the fish that they call the loser fish, I would never call that fish the loser fish. This is not my language; it's their language. But the behavior starts to change significantly, and they start to behave as though they're not the loser fish. So again, we don't want to ascribe too much meaning to this, but we want to also, I think there is significant meaning that we can ascribe. We know that the serotonergic system is very much involved in mood in humans. We know that when we experience status descent in our lives, humiliation, loss, that if somebody, if you get some terrible news, right, you and somebody says, how do you feel, and you do an inventory, you might say, I'm really sad, or maybe you'd say, I'm even depressed. and that actually there is a theory called the social defeat model for depression that kind of takes the idea that the origin of the brain neurobiology that contributes to depression and to mood disorders in us, that actually evolved in our ancient animal ancestors as part of this social brain network to navigate these social hierarchies. Now, how does that have to do with what you're asking about social media? Well, I think a lot. I really do. Because if you think about what social media is, and if you're a 15-year-old girl and you're on whatever you're on, Instagram, whatever, it's really about comparison, all of it. How many likes, how many followers. It's about um, rising and falling in status and comparing yourself to the beauty of the other individuals, the popularity of the individuals, the marvelous lives that they're apparently all leading. It's comparative. So I call this the neurobiology of comparison. And so if you sort of ask the question, why does social media affect adolescents, their mood so much? I think one evolutionarily framed explanation an argument can be made that some component of it relates to this brain biology, which has the this change in neurobiology in response to falling in status. And there are other questions that come. Well, you might say, well, why would that evolve? I mean, how could that be adaptive, right? How could that be fitness enhancing? And it's a great question. It's the right question. And about 18 months ago, maybe now 2 years ago, a group in Norway did a fascinating experiment. They took rainbow trout, actually, and they created a bunch of loser rainbow trout. And then they had a number of dominant trout. And they did these series of experiments, and half of the loser rainbow trout they gave ketamine to. They dosed them with ketamine.
Yes.
Ketamine rapidly changed their neurobiology, and very quickly they went from being withdrawn, not moving very much, to acting like they were high-ranking fish. And they went and there were dominant fish in the tank. And so all of a sudden the dominants started to attack them and really get them.
Wow.
Whereas the fish who had fallen in status, the trout they were the control group, they weren't treated with ketamine, they were safer. They were not attacked.
Wow.
Right?
So, yeah, yeah, that link is phenomenal. And for those listening, ketamine is used for anesthesia, and also it can be, I think, in some settings like a psychedelic. Just kind of want to clarify. We're not saying there's a correlation, but just want to clarify what that molecule is. But that is so fascinating. And I think in your book, you called it a specific word, going back to the social media thing and how we rank ourselves among society and how that affects us. And you called it assessment overload. That it
Yeah.
seems that it seems like when you're in a community, you have friends and you have, people that you're interacting with on a daily basis, and that can be fairly healthy. But when you expand that to thousands and thousands of people who you don't know their ups and downs, and you compare yourself to them, the assessment is just overloading your brain and that kind of neural biology networks that you're talking about. So can you talk a little bit more about that?
Gabriel, you read so carefully. Gosh, this is an unexpectedly like just yeah. Again, I don't think I'm sure I've not had a former 186 student interview me
Yeah.
and read so
Well, that
carefully.
means you taught the class and you read the book. I mean, you wrote the book so well.
Okay, you're good. You're good. Um, Yeah, so the this kind of touches on a concept in evolutionary medicine, which is called mismatch, right? So sometimes one of the hypotheses we have is that some human diseases, modern human diseases, are a consequence of something happening in the environment that our evolved physiology it didn't evolve to deal with at that level, right? So the classic example is obesity, right? There's an obesity epidemic. So many people are overweight and obese. And one of the ways we can understand that is to, from an evolutionary perspective, to say, well, as we look at the animal metabolism that we as humans have inherited, that metabolic machinery evolved in the wild, and in the wild, caloric scarcity is a clear and present danger, right? Animals in the wild die of starvation, infection, predation. Starvation is a big, big danger. And so one would predict that animals would have evolved metabolic machinery that would protect them as much as possible from starvation, protect them from starving in a world where access to calories is uncertain. And so if we've inherited that metabolism, but now we're in an environment which is just, whatever. I mean,
Twinkies, hot Cheetos.
everywhere without any effort at all. So that's a mismatch, right? And that obesity emerges because the obesogenic environment that we find ourselves in meets this animal metabolism that's evolved to be, calorie sparing. So in the case of this social brains that, we know exist in fish, right? They've been around hundreds of millions of years. So we believe that suggests that social assessment is an important ability for animals to have. But maybe in the modern era, just like we have Twinkies and food absolutely everywhere, what's happened is that in every single domain of a young, high school students, right there in class, they're being assessed academically. Sports and athletics and all that, they're being assessed there. There's beauty, right, and bodies and all of that, which is like a whole other stress of being, I mean, at every age, but I mean, especially in middle school and high
Yeah.
school. And then to make matters worse, so maybe that existed when I was in high school, but here's what didn't exist. I would maybe come home and close the door and whatever, throw myself on my bed. But now me today would open up her laptop, and all of a sudden there's more assessment, and you never win, right, with social media. So that's this idea that maybe part of the kind of understanding why social media is having this toxic effect is that there's this evolved ability to deal with some assessment, but it just can tip over into this toxic overload, and that's what we called assessment overload.
Yeah, and what you were mentioning about being able to go home and like just relax from everything, I actually never thought about that. Like being able, 20 years ago, you go home and you're with your family who love you, who care about you, who don't care, compare you. But now you go
Right.
home and that comparison is just
Yeah.
there, there, and there. And yeah,
Yeah.
that's a lot to deal with for sure.
I have to say, it's a total game changer from, I mean, social media, actually, when you were in high school, what social media were you using? What was
It
the
was
thing?
when I was in high school. It was very just starting. I think in eighth grade there was MySpace, and I was
Okay.
on MySpace with the top three friends. So you see how easy it is for us, human monkeys to rank ourselves, so young. MySpace, but then I think Facebook and Instagram started getting popular in high
Got it.
school and towards the end. Yeah.
I mean, it does not feel good to feel like you're on the bottom end of a hierarchy in a group that you care about. Right. And one of the beautiful things about the end of high school and the beginning, like middle school, it's a popularity contest. And it's kind of like whatever, beauty, good at sports, have the right, whatever. But by the time and we've read about this in Wildhood, and there's studies on this, that by the time, I forget whether it's 10th to 11th, whatever, prestige hierarchies start to emerge. So all of a sudden, yeah, maybe you're not the coolest kid in the school, but you really love whatever, orchestra, violin. I'm not talking about anybody specific. No, that you find your people and you find hierarchies that are meaningful to you, and that's kind of like what is. I think when you grow up, you decide that I may decide that I'm never going to be that, and that's okay because I'm this, and this is what I care about, and these are my values, and this is
Wow.
the hierarchy I care about.
That's such
Yeah.
Yeah, that's such a great point. And I think the quote is like they'll make fun of you for something when you're in middle school and high school that they'll praise you for when you're an adult. Like you're saying, like the
Absolutely.
writing or the thoughtfulness or your interest in music. Um, and I was actually very I would think about this a lot. Like, why do humans care so
Mhm.
much about rank or status? But then when I saw what you mentioned in the book, prestige, hierarchy,
Mhm.
and I was like, wow, that makes so much sense. That like it's not about being better than anybody. Is that and you're not trying to impose yourself. People respect you and love you and care about you because you're a unique individual who has so much to offer. So prestige hierarchies, I think, yeah,
Right.
that's a great
Yeah.
concept. Um,
That, and there
so
aren't a lot of things I don't emphasize what's uniquely human, but I do think that's a probably one could argue that that's a uniquely human, wonderful that it is uniquely human. Yeah, I love that.
yeah, for humans, we got one on the board at least. So
Great.
I have a few final questions that I want to ask you. Um,
Sure.
one of them is about romance in the animal kingdom, and the other one is about kind of what do you want the world to know about your work. So those are two separate questions, but I think kind of I want you to choose which one you're interested more in talking about.
Well, I'll say one thing about animal romance, and then I'll lean on the second part. So, um, as you know, in my class, that there is, I think, a huge amount we can learn about human sexuality from animal sexuality. And a couple of the highlights are that there is a lot of non procreative sexual activity. So some of it is between male and female animals, some of it's between male and male animals, some of it's female female. The point is that there's lots of non procreative, in other words, sexual acts that don't make offspring, and that the reasons for that we're beginning to look at. But I guess I had this assumption before I had this kind of ubiquitous moment 15 years ago that in human life, we have sex for all kinds of reasons. Yes, to make babies, but also, for all the reasons human beings have sex. But I had this idea that in nature, animals have sex to make offspring, and that was it. And that is absolutely not the case. So that is sort of an interesting insight. And then a corollary to that is one of the points I make a lot now in my class is that when you watch those wildlife documentaries and you see like courtship, you see the bird of paradise, the male is sort of on the log doing this, and then the camera turns to the female, and then you see the male. And very often it's portrayed as performative, where the male is sort of showing and the female watching. Not always, but very often the term courtship ritual is used, or courtship dance. And here's my pet peeve with that is what's actually going on in courtship is a conversation between two individuals. Do we want to? Do I want to? Do you want to? Are we gonna? Is it gonna happen? Yes, no. Like there's this, it's a back and forth. It really is. And and if you look at now, it's been studied heavily in Drosophila. I mean, there's many micro conversations. And what is a ritual? Well, a ritual is something that has a predetermined outcome, and a dance has specific steps, right, that are always the same. Courtship is a conversation. It does not have a definite outcome. And I think that as our conversation about consent and about um, sexual communication, one of the ways we can strengthen, expand, make more interesting our conversation is to remember that about human sexual communication is to really move away from this language of courtship, kind of like this is what you do to have X happen. That's wrong. So anyway, there's more we
Yeah,
could say about romance,
yeah,
but
like the
but
yeah,
you asked.
Disneyland portrayal of the white in shining armor and the damsel in distress, and you're kind of saying that, oh no, it's more two parties communicating, coming together, and having a conversation.
Right, and that there's decision making, and that it's again, there's lots of variation, but just to kind of keep that in mind, that when you're looking at nature, it if it happens in human life, it is far more likely that it's happening in animal life than that it is not. That's sort of the concept. And that would be how I would kind of end and answer your second question, which is this lens, this lens that I apply to all kinds of anything I'm interested in. I apply this ubiquitous lens. So it's a lens that looks at a human question, and it looks across species and evolution to see whether, you can discern something that you haven't seen before, either understand it better or maybe solve it better. It makes so much sense. And as a physician who spent, a couple of decades not having that lens and not even knowing that it was something that I didn't know that I was missing anything. But being that person, I can tell the people who are listening to this, who are physicians or medical students or patients or psychotherapists or anyone, that if you learn how to look at think of your human problems and then turn to the natural world and apply a lens, that you will absolutely find a way to understand it better. And in some cases, you may actually find a new strategy that's more effective than what you've been doing before.
Totally. And Dr. Natterson Horowitz, it's been a pleasure speaking with you. You've inspired me to change the way I think, and I do apply it. And for all my friends who know me and talk to me, they're probably annoyed of me talking about chimps and gorillas and wildebeest and how it applies to human. But so thank you for giving me this lens. I appreciate it. Where can people find you? Where can people find you, and where can people, learn more about your work, your books, and your research?
Right. So I have a website I've been working on, which is bnatterson-horowitz.com. And you'll see some videos in there and a lot of information about our research. And then we do Ubiquity conferences in the past, where we bring together medical schools and vet schools in fact, UC Davis Vet Med was wonderful partners for the first two Ubiquity conferences. And then the usual places, but the website is where I've been focusing some energy in the last couple of months. So that would be the
And
place.
also, they're on Amazon. I don't know if you prefer a certain bookstore, but the books are on Amazon. Phenomenal reads, phenomenal storytelling. So please check it out. And then once again, thank you for coming on.